Okay, so this is still chapter 9 that we're in.
Shut up, you thought you were
It's all right triangles. So, first we did finding lengths of sides using geometric means. Okay, if you had a triangle like that, which is 3 right triangles, there's a big one, this little one, and this medium-sized one. Then we did using the Pythagorean theorem. If you know 2 sides, you can find the 3rd side, right? Yeah. And then we did the 45-45s. On a 45-45, the legs are the same, and the hypotenuse is just the leg times the square root of 2. And then we did the 30-60-90s, where the hypotenuse is just double that. The long leg is just the short leg times the square root of 3. So that's not the only type of right triangles there are. Sometimes you know one side and you know the angle.
Can I help you?
Like here, if it's a 30-60-90, all you need to know is one side and you can figure out the other 2. If it's a 45-45, all you know is one side and an angle, you can find the other 2. But if it's not those degrees, if it's any other than a 30-60 and a 45-45, that's where these trig ratios come in that you use to find. Okay? So that's what we're doing now is right triangles where you are going to know, well, the added thing now is we're not only going to find all the sides, you're going to find all the angles. So you're either going to know 2 sides or a side and an angle. And then you got to find the other missing stuff. So,
This is not too easy.
it is easy.
Maybe to you because you are actually passing.
Oh.
Or you actually passed. I'm not. I'm far from
Okay.
You got it.
The trigonometric ratios, trig ratios. It has an acronym like PEMDAS, you know?
Yeah.
Parentheses, exponents. The ratios, it's this. SOHCAHTOA.
That sounds Indian.
It does.
I'm sorry, I didn't mean to be racist.
Mason, you hear that?
Yep. So, there's 3 trig functions. So, this represents the first one, the second one, the third one. So, the trig ratios are sine, which on your calculator, I'm sure you've seen it. They don't put S-I-N-E, they just put S-I-N.
Uh-oh.
So it says sin, but it's pronounced sine. And then there's cosine, but again on the calculator, they just put C-O-S. And then the third one is tangent, which on the calculator, they just use tan. So it's sine, cosine, tangent. Okay? Now, this one right here, on any triangle, again, if you know an angle, we'll say this is 70 degrees. There's 3 sides, right?
Yes.
Everyone knows the hypotenuse. Then, this is where they come up with these words. This side right here and this side, they're both legs. So this is called the adjacent leg. Remember what adjacent means?
Right next to.
Right next to. This is also adjacent, but it's not a leg, it's the hypotenuse. And this side, then, it's called the opposite leg. Okay? So you need to know how to distinguish which is opposite, which is adjacent, which is the hypotenuse. Okay, that's the main part. If you know that, this part's easy. So what it is then is the sine equals the opposite over hypotenuse. That's where they get the SOH. So here, if I were to write the trig ratio of this, it would be the sine of 70, because that's the, I should put, they use Greek letters instead of A, B, C, and X and Y for the angles. So if it's a missing angle, they either use, that's called theta, alpha, or beta is used a lot. It's the same thing as calling it an X. It's just a missing angle. So the sine of this angle, 70, equals the opposite leg. So we'll just say this is a 6, 8, 10 right triangle. So the sine of 70 equals 8 over 10. Opposite over hypotenuse. 8 is opposite of 70, 10 is the hypotenuse.
Yeah.
Now, eventually, all we're doing today is we're writing them out. We're not solving anything. Eventually, what's going to happen, here we know everything. But eventually, one of these three things will be missing, and you got to find the missing value. But today, we're just writing it out. Cosine. So cosine would be adjacent over hypotenuse. So the cosine of 70 is 6/10. And then tangent is
Opposite over adjacent.
opposite over adjacent.
I feel so smart. Yeah, I need
So the tangent of 70 is 8/6. Now, I just made this up. It's not exactly right. I think it's like 67 or something. So this, if we check this, it wouldn't be correct, but I'm just showing you how to write it. So, that is the trig ratios. SOHCAHTOA. SOHCAHTOA. So, angle of elevation and angle of depression are exactly the same thing. In word problems, like an angle of depression is, they use a lot of examples, like if you're in an airplane.
Ow! Don't touch me, Cleo.
Okay? If you're in an airplane and they say if they're going to land, their angle of depression is like 30 degrees. That means if you're looking out on the horizon and you go down from that, that's the angle of depression. Okay, so it's the angle formed with the horizon. An angle of elevation would be like, say, someone standing down here looking up at the airplane. That would be looking out and up. They're alternate interior angles. That's why angle of elevation and angle of depression are always the same in a word problem. Okay? So angle of depression is just looking out and down. Angle of elevation is looking out and up. Okay? So, today it's real easy. We are just going to find the sine, cosine, and tangent of a certain angle. So they want angle P. So all we're doing is writing the trig ratios like we did there. We got to find the sine of P, the cosine of P, and the tangent of P. So as long as you remember SOHCAHTOA, sine of the angle P is the opposite side over the hypotenuse. So it'd be what over what? 15/17. That's all it is. Cosine is 8/17. Adjacent, which is 8, over the hypotenuse, which is 17.
So it would be 8.
15 over 8, right. Opposite is 15, adjacent is 8. Okay?
Calm down. You're good.
Okay, now this one, they throw these in every once in a while. This is a 30, 60, 90.
So just find this inside.
So if the short leg is 1, what's the hypotenuse?
2.
2. And the long leg is?
1 square root of 3.
1 square root of 3.
Wow, Mason, you're so smart.
Thank you for noticing.
So, if we were to write out the 3 trig functions, the sine of 60 is Opposite over hypotenuse.
Oh.
Square root of 3 over 2. Opposite over hypotenuse. Cosine of 60 is adjacent over hypotenuse.
1 over. And then it's square root of 3 over.
Square root of 3 over 1. Okay. The sine of x is
Opposite over
16 over 20, right. Opposite is 16, hypotenuse is 20. Cosine of x is 12 over 20. And the tangent of y, they're switching things up.
Oh, 12 over.
Yep. Tangent is opposite over adjacent, so 12/16. Now, here's what's going to happen. If they tell you to find the sine, cosine, and tangent of each missing angle, you only got to do this because you always know this is 90, so there's only 2 of them. So you'd find the sine of x, the cosine of x, and the tangent of x. When we actually take the test at the end of this is a problem on the test. You got to find the sine, cosine, tangent of x, and sine, cosine, and tangent of y. So the sine of x we already figured out is 16/20. Cosine of x is 12/20. Tangent of x, 16/12. When we do the sine of y, it's opposite over hypotenuse, it's 12/20. Cosine of y is 16/20. 12/16. So if you look at these, and this is true in every right triangle, the sine of one angle is going to be exactly the same thing as the cosine of the other angle. They'll end up being the same value.
That's true for all.
For all right triangles, yep. Here, the cosine of this angle is the same as the sine of that angle, of the other one. And then how do these compare to each other? Reciprocals, yep, inverse flipped. That's really all it is. We're not going to do the solving yet, like here. But just to give you an idea of what we will be doing next. If you notice here, we know a side and we know an angle, and they want you to find this. So, this is what you eventually got to do. You got to figure out, do I want to use sine, cosine, or tangent? So, of the given sides, are they adjacent, or opposite, or hypotenuse?
They're adjacent.
Adjacent and opposite.
Yay!
Okay? The hypotenuse, they don't want to know it, it's not being asked. So which trig function involves adjacent and hypotenuse, or opposite? Tangent. So it'd be the tangent of 64 equals opposite over adjacent. And here you got a formula. What would you do to get the h by itself? Times it by 19. So on your calculator, you would just go 19 times, use that tangent button, 64, and it'll press equals, and it'll tell you how long it is.
What's the answer?
Well, let's see.
Oh shit.
3.
Yes, sir.
It is 38.95, so it would round to 39 feet.
How does that make any sense?
Okay, but we're not solving yet. We're just writing the ratio.